Welcome back, guys. So, what we're going to talk about today is another part of the reason we have seasons. So, you learned last week that we have seasons, and the main reason we have seasons, and that is the Earth is slightly tilted. But we also have seasons because of the Earth's rotation and revolution around the sun. More importantly, more specifically, the Earth's revolution. Because of the Earth's revolution and the fact that the Earth is on a tilt, so like the axis is tilted, are the two reasons the Earth has seasons. And today we're going to learn three new vocab words and learn how they impact the Earth. Let's get started. So first I want to talk about Earth's orbit. Now, before I even get this far into it, I want to specify and I want to make sure we're all on the same page. Orbit and revolution are very similar, but the orbit is the path the object takes. Revolution is the motion of the Earth, or the motion of an object going around another object. So orbit is the path. So we're looking at the path it took. Revolution is the actual process or the motion of it happening. So, what are their definitions? Orbit is the path an object takes as it moves around another object. So in this case, the orbit is the path the Earth takes as it moves around the sun. Revolution is the motion of one object around another object. That means the motion of Earth around the sun. The sun does not revolve around the Earth revolves around the sun, as I'm sure Mrs. Haynes has taught you in social studies. Okay, so the pathway in which the Earth takes around the sun is the orbit. So we're seeing the pathway. The Earth is traveling this way around the sun. You'll also notice the moon revolves around the Earth, but we're not going to worry too much about the moon right now. But the Earth is revolving around the sun, and when it does that, we get a path or an orbit. That's why we have these little dots here. Okay, then we have rotation. Because of rotation, we get night and day. So rotation occurs while the Earth is revolving. Now, I'm sure you've all spin or span something. That's what rotation is. When it rotates, it's spinning. So the spinning of the Earth is the rotation of the Earth. The Earth does not rotate quickly, it rotates slowly. Like we don't feel the Earth rotating. But obviously, because we get night and day, the Earth does one complete rotation in 24 hours. One half of the day, the Earth is facing the sun. The other half of the day, the Earth is facing the moon. And because of that, we get night and day. So, as I already said, while revolving around the sun, the Earth is spinning or rotating. Rotation is the spinning motion of Earth. Rotation axis is the line in which an object rotates. And rotation helps produce the Earth's cycles of day and night. So again, because Earth is rotating, part of the day it's facing the sun, we have day. Part of the day it's facing the moon, we get night. It's not the revolution that gives us day and night. It's the rotation. Now, I put this up here just as a visual. One Earth year is 365 days. One Mars year is 687 Earth days, or 669 Martian days on Mars. And notice, we're getting the pathway, the orbit of the planets. The pathway. Now, you already learned about this last week. The Earth is on a tilt. So during half of Earth's orbit, the north end of the rotation axis is towards the sun, and during the other half, the north end is away from the sun. And that's how we get seasons. So just know, the Earth's axis is tilted, that's how we get seasons. Now, last week you learned the Earth is actually closest to the sun in January. But we're in winter when that's occurring. Seasons are caused by the tilt of Earth's rotation axis, combined with Earth's motion around the sun. So again, I'll say it one more time. Seasons are caused by the tilt of the rotation axis, the fact that the Earth is tilted, with the revolution or the motion around the sun. So Earth's revolution around the sun and the fact that it's tilted are the two reasons that we have seasons. And then we talk about the seasons. So in the northern hemisphere, which is where we are located, we are in the northern hemisphere. Spring and summer. Let's look at that. One half of Earth's orbit, the northern hemisphere receives more energy from the sun than the southern hemisphere. So because of that, temperatures increase in the northern hemisphere and decrease in the southern hemisphere. Obviously, if we're getting more energy, we're getting hotter. If we're getting hotter, we're in summer or spring. If we're getting colder, we're in winter. So during the spring and summer, the northern hemisphere is getting more sunlight, so we're getting higher temperatures, which is why we're in spring or summer. Daylight hours last longer in the northern hemisphere, and nights last longer in the southern hemisphere. So in the northern hemisphere, daylight hours are long, night hours are shorter. In the southern hemisphere, nights last longer, days are shorter. And that makes sense because when the northern hemisphere, when we're in winter, the sun goes down at like 5 o'clock. So our daylight hours are shorter, but our night hours are longer. The same thing that happens to us in winter happens to the southern hemisphere during their winter. And we're just reversed. So the southern hemisphere has winter and fall, or fall and winter, during the same time we have spring and summer, because they're on the opposite end of the Earth. And obviously I don't have to tell you why we're looking at the northern hemisphere, because we live in the northern hemisphere. Then with fall and winter in the northern hemisphere, it's the complete opposite. So during the other half of the orbit, the north end is far from the sun. The northern hemisphere receives less solar energy than the southern hemisphere. So temperatures decrease in the northern hemisphere and increase in the southern hemisphere. Our nights are longer, their days are also longer. It's just the complete switch. Opposite ends of the Earth, opposite effects. Now, this is a picture. So this was one of your questions last week. We have solstices and equinoxes. The equinoxes are when the Earth is getting equal amounts of sunlight. So you'll notice in March, the whole Earth is getting sunlight. In September, we're all getting less sunlight. Then we have the June solstice and the December solstice. In the December solstice, you'll notice the southern hemisphere is getting the light, the northern hemisphere is facing away, so it's not getting as much light. Because the angle is different, the northern hemisphere receives less energy, where our daylight hours are shorter and we're colder, so we're in winter. Whereas the southern hemisphere is facing the sun, they get all the energy, their days last longer, they're in summer. Then you'll notice in the June solstice, the exact opposite occurs. The northern hemisphere is facing the sun, and because of that, we get more temperature. It increases on our side of the earth. Our days last longer, and we have summer, and the southern hemisphere has winter. So this is the perfect visual to show you what happens. And just to recap, our equinoxes mean the Earth is receiving the same amount of sunlight. Both hemispheres are receiving the same amount of sunlight. The solstices are when there's a difference. And I believe that's it. Yep. Okay, so now what you're going to do is make sure you go back through the PowerPoint and finish the notes, and then answer the exit ticket. If you have any questions, feel free to message me on Google Classroom. Have a wonderful day.